We've been learning about similar figures. One of my favorite similar figures are these two folks, Dr. Evil and Mini-Me. Mini-Me is exactly like Dr. Evil, only smaller. So let's get a definition of similar figures. Similar figures are similar if their corresponding angles are congruent and their corresponding side lengths are proportional. So we should know that already from yesterday's lesson. But why don't you pause the video and write this down in your DPT packet so that you have it for later. So one thing that's really important is to learn about a similarity statement and how to use it. It can be extremely helpful. If you know that these two figures are similar, if you know that ABCD is similar to EFGH, then there's a number of things that you can say based on that similarity statement. Don't forget the similarity symbol is the single squiggly, which some of my students have recently told me is called a tilde when it's on a keyboard. So that's interesting. So let's say hypothetically that we knew that angle C was 110 degrees. How could we use that information? Well, we can use our similarity statement to say, all right, we know that angle C is congruent to which angle? We know that angle C from the similarity statement has to be congruent to angle G because they're each in the third spot. So you could come on over here to angle and you can mark that G is congruent to C, and if C is 110, that would mean G is 110 too. So there's a lot of things you can say. You can say all four pairs of angles are congruent to each other. In other words, you could say that angle A is congruent to angle E, and you could say angle B is congruent to angle F, and you could say angle C is congruent to angle G, and angle D is congruent to angle H. So when you're first looking at this diagram, you may or may not see what C goes with, but you don't want it to be a guessing game. You don't want to say, oh, I think I know what goes with angle B. Angle B looks like it goes with, some angle over here. You want to literally say to yourself, the second letter B goes with the second letter F, and now I know that B and F are congruent. So it might be helpful to go ahead and mark the rest of these. B is congruent to F, and then we know that C is congruent to G, so we did that already. We know that A is congruent to E, so we could do a triple for A and a triple for E, and so on and so forth if we want to mark angles congruent to each other. Another really important thing to go over with similarity is the statement of proportionality. So I'm going to actually clear this image for a little and show you how to write a statement of proportionality. So when you're writing a statement of proportionality, if there's four sides, you're going to need fraction bars. You're going to need four of them. If there were three sides, you would need three fraction bars, and so on and so forth. But since this is a quadrilateral with four sides, we're going to get ourselves set up, and we're going to say the length of AB, the first two, is to the length of EF, as the length of BC, the second two letters, are to the length of FG, the second two letters, as the length of CD is to the length of GH. And when we finish this up, we're going to go first to last. We're going to connect A to D, and we're going to say as AD is to EH. It's really important to be consistent. If you start with if the top is the ABCD, then all along the top you should have the letters from the first quadrilateral, and at the bottom is the second quadrilateral. It should stay consistent, and all of the letters should be on the bottom. So you might be wondering how we're going to use a statement of proportionality. Let's say we had two similar figures, and you knew some information about those two figures, but some information was missing. We're going to see how you'd use the statement of proportionality to find it. I think we need the word of right there. Okay, so we're going to create another set of fraction lines so that we can fill into them, and we're going to see what we know. We know that AB has a length of 24 centimeters, so we'll put that in the top left because AB is in the top left. And it goes over EF, and EF is X, so we'll put X on the bottom. And then BC, we know is 14 centimeters, and we also know that FG, well, we don't have anything, so we'll put a question mark there. We want to know what CD is. We have that at 6 centimeters. And we want to know GH next, and we don't know GH, so we'll put a question mark. We know AD is 16 centimeters, and EH is 12 centimeters. So at this point, we've got 4 fractions, but only 2 of them are really completed. So we're going to pair this guy up with this guy and create a proportion. It's already a proportion. We're just going to focus on the part we want, which is 24 over x is going to be equivalent to 16 over 12. And at this point, you're just going to solve this proportion. So 16 times x is 16x, and 24 times 12 is 288. And then we're going to divide both sides by 16. And when you divide 288 by 16, I believe you get 18, and the label is going to be centimeters. So basically, you use the statement, the similarity statement, rather, to write a statement of proportionality, and you use the statement of proportionality to help you plug in and solve proportions to find missing side lengths. So I know this video is getting a little lengthy, but there's one more thing that you folks need to know about before you kind of get started on today's work is scale factor. Scale factor is a ratio that compares, the size of the bigger figure to the size of the smaller figure. So in this case, we could take any 2 sides that we know, pair up with each other. So we could take, for example, 16 over 12, and we're going to simplify that to find the scale factor. 16 over 12 simplifies to 4 over 3, and the scale factor is typically written as 4 colon 3, which means the relative size of the big one is, for every 4 parts the big one has, the small one has 3 parts. So you could say they're in a ratio of 4 to 3. Now, when you're asked for scale factor, you're usually asked for a scale factor of 1 to another. So let's say somebody hypothetically said, give me the scale factor of EFGH to ABCD. Then we would start with a number in EFGH. So let's say we started with, well, let's fill in X. We now know X is 18. So let's say we started with 18, and we put that over what 18 goes with in the other figure, which we know is 24. We simplify that, and we get 3 over 4, which means the scale factor of EFGH to ABCD is 3 to 4. It's just a flipped over version of the other scale factor, 4 to 3. It doesn't matter what pair of sides you pick, they're always going to simplify it to the same thing. And so one way is that the smaller figure, EFGH, is 3/4 or 75% of the size of ABCD. So after watching this video, here are the really important things you need to have taken notes on and be familiar with. We've got definition of similar figures. We've got the similarity symbol, which looks like that. We've got a similarity statement, which looks like triangle ABC is similar to triangle DEF. We've got the statement of proportionality. You know what that looks like. It's with the fraction bars, AB over DE, and so on and so forth. And then we've got the scale factor, which is written like one number to another number, and it shows the relative size comparison between 2 figures. So hopefully that all makes sense to you, and you can move on and try out some of this stuff.